Hello everyone, welcome to my channel. In this video we are going to discuss about natural numbers and whole numbers and their properties like closure property, commutative, associative, distributive, identity and inverse. Natural numbers are also called as counting numbers, and these numbers we use for counting purpose. Now let's discuss about some facts about natural numbers. The first and the smallest natural number is 1. Second is the last and the greatest natural number cannot be obtained. Third one is the difference between two consecutive natural number is 1. Means if I subtract 3 from 4, I will get 1. 4 minus 3 is equal to 1. And 10 minus 9 will be equal to 1. Next we have, if we add 1 to any natural number, we will get next natural number, or we can say successor of that number. For example, if I add 1 to 3, 3 is a number and I am adding 1 to this, I will get next number. Means successor of 3 is 4, we know. So similarly, if I add 10 plus 1, I will get next number or the successor of 10, which is 11. And fifth one is, if we subtract 1 to any natural number, we will get previous number, or we can say predecessor. Means if I subtract 1 from 3, I will get the predecessor of 3, which is 2. Similarly, if I subtract 1 from 10, I will get 9. 9 is the predecessor of 10. The predecessor of 1 is 0, but 0 is not a natural number. So we can say that 1 has no predecessor. Next we have whole numbers. Whole numbers are 0 plus all natural numbers. Now some facts about whole numbers. First one is 0. 0 is the first and the smallest whole number. Second fact is, the last and the greatest whole number cannot be obtained. Why? Because we have infinite whole numbers. Third is, the difference between any two consecutive whole numbers is 1. Next is similar to natural numbers. If we add 1 to any whole number, we'll get successor to that number. For example, 3 plus 1, I will get successor of 3, 4. 9 plus 1, I'll get 10, the successor of 9, like this. And fifth is, if we subtract 1 to any whole number, we will get its predecessor. Similar, means 9 minus 1, I'll get predecessor of 9, which is 8. 10 minus 1, I'll get 9, the predecessor of 10, like this. All whole numbers have their predecessor, but 0 has no predecessor. The main properties of natural numbers and whole numbers for the operations of addition, subtraction, multiplication and division are closure property, commutative property, associative property and distributive property, and we'll apply all these properties to the operation addition, subtraction, multiplication and division. First, we will do this closure property for natural number as well as for whole numbers. For all the operations, we will get 7. 4 is a natural number, 3 is a natural number, and 7 is also a natural number. Any number 50 plus 57 if I take, so it will become 107. So these two are natural numbers and this is also a natural number. So we can say that natural numbers are closed for addition. So we write here, yes, they are closed for addition. Now let's see for subtraction. Means A and B are two natural numbers. Then their subtraction means A minus B also a natural number. Suppose A is equal to 7 and B is equal to 3. So 7 minus 3 is equal to 4. This is a natural number. But if I take A as 11 and B as 13, then it will become minus 2. And minus 2 is not a natural number. So what here we can say that natural numbers are not closed for subtraction. So we'll write here no. Property for multiplication means if A and B are two natural number, then their multiplication means A multiplied by B is also a natural number. Let me take one example. Let's suppose A is equal to 2 and B is equal to 3. So 2 into 3, which is equal to 6. This is a natural number. So we can take any numbers and we'll see that the multiplication is coming under natural numbers only. So we can say that natural numbers are closed for multiplication. Yes. We'll see this property for division. It means that if A and B are natural number, then their division is also a natural number, A divided by B. This will be a natural number. So let me take A as 3 and B as 4. So 3 by 4. Is this a natural number or not? Not a natural number. So we can say that natural numbers division is not closed. So we can write here no. And similarly, if we apply this closure property for all the operations for whole numbers, we'll find the same result. Means whole numbers are closed for addition. Yes. For subtraction, they are not closed. And for multiplication also we'll get yes. And for division we'll get no. Next we have commutative property. Let's do it for addition. Two numbers A and B are said to be commutative for addition if A plus B equal to B plus A. Let's take one example. If A is equal to 7 and B is equal to 3, then A plus B is equal to 7 plus 3, which is equal to 10, and B plus A equal to 3 plus 7, which is equal to 10. It means A plus B equal to B plus A. So A and B are commutative for addition. So we can say that yes, natural numbers are commutative for addition. We can write here yes. Let's do this property for subtraction. Means if A and B are natural numbers such that A minus B equal to B minus A, then these two numbers are said to be commutative for subtraction. Let's do this. A equal to 7 and B equal to 3. Then A minus B equal to 7 minus 3, which is equal to 4. And B minus A equal to 3 minus 7, which is equal to minus 4. So from here we can see that A minus B is not equal to B minus A. So we can say that A and B are not commutative for subtraction. So we can write here that natural numbers are not commutative for subtraction. No, we can write here. Now let's see whether natural numbers are commutative for multiplication or not. Let's take two numbers A and B. Then two numbers A and B are said to be commutative for multiplication if A into B is equal to B into A. Let's take A equal to 5 and B equal to 2. So A into B is equal to 5 into 2, which is equal to 10, and B into A equal to 2 into 5, which is also equal to 10. It means A into B is equal to B into A. So it means A and B are commutative for multiplication. So we can say that natural numbers are commutative for multiplication. So we can write here yes. Do this division. So here if A and B are two natural numbers, then A divided by B must be equal to B divided by A, which is not true. We know, not true. So we can say that division of whole number is not commutative. So we can write here no. We can prove this also. If I take A equal to 3 and B equal to 4, then 3 by 4 is not equal to 4 by 3. So we can write here no. And if we apply this commutative property for all the operations, addition, subtraction, multiplication and division, for whole numbers will get same result. Means the whole numbers are commutative. For addition, here we'll write yes. For subtraction, they are not. And for multiplication also yes, and division no will come. Associative property is similar to closure property, but here we use 3 or more numbers. According to this property, the sum of the numbers will remain same irrespective of the manner in which they are grouped. Suppose I take 3 numbers A, B and C. All these 3 numbers are natural numbers. Then A plus B plus C is equal to A plus B plus C. Means the sum will remain same whatever group I use. First here I have grouped A and B, and here I have grouped B and C. Let's take one example. A is equal to 3, B equal to 4 and C is equal to 5. Then A plus B plus C is equal to A is 3 plus 4 plus C is 5. 3 plus 4 is 7 and 5, which is equal to 12. And now A, B and C. So here A is 3 plus B is 4 and C is 5. This will become 3 plus 9, which is equal to 12. So addition of natural numbers satisfy associative property. So we can write here yes. Now let's see this property for subtraction. Again we have to take 3 numbers. Then we'll do like this. First I'll take this group, and after that A minus B minus C, I'll take this group. Let's see whether this is correct or not. So I'll take A equal to 3, B is equal to 4 and C equal to 2. So first A is 3 minus 4 minus C is 2. So first we have to subtract this. So it will become minus 1 minus 2, which is equal to minus 3. And similarly A minus B minus C. A is equal to 3 minus B minus C. B is 4 minus 2, which is this 2. This is equal to 1. And these two are not equal. That this is the subtraction of natural number does not satisfy associative property. So we can write here no. Now let's see that the multiplication of natural number satisfy this associative property or not. So for this we have to take 3 numbers A, B and C. All these are natural number. Then A into B into C is equal to A into B into C. Now here same. That the grouping, the order of the grouping does not change the multiplication of these 3 numbers. So for that also I will take one example. A equal to 3, B is equal to this and C equal to 5. So A into B, 3 into 2 multiplied by 5 is equal to 6 into 5, which is equal to 30. So next I will take this group. So A is 3 into B is 2 into 5. This is equal to 3 into 10, which is equal to 3. Both are equal. So we can say that the multiplication of natural numbers satisfies associative property. So we can write here yes. Now let's do this property for division. Here also we have to take 3 numbers, 3 natural numbers. Then we'll find out that A divided by B, if I take this group, and is not equal to A divided by B divided by C. So we can say that division of natural number is not associative. So we can write here no. And similarly for whole numbers also we'll get same result as the natural number. So whole numbers are the addition of whole number is associative. So we can write here yes. The addition of whole numbers is the subtraction of whole number is not associative. We can write here no. Same, the multiplication of the whole number is associative. We'll write here yes. And the division of whole number is also not associative. So we can write here no. Next is distributive property, and for this property we need two operations at a time: multiplication and addition, and multiplication and subtraction. So we'll see that what this property says. So for natural number, I'll take here same three natural number A, B and C. These are three natural numbers. So according to this property, if I do like this, A into B plus C, okay, is always equal to, if I multiply like this, A multiply by B plus A multiply by C. If I multiply like this, so let's do A I'll take 4, B I take 3 and C I take 2. So first A into B plus C is A is 4, B is 3 plus 2. So this is 4 and this is 5, which become equal to 4 into 5, which is equal to 20. So I'll take next A into B plus A into C. A is 4 into 3 plus A is 4 multiply by 2, which is equal to 12, and this is equal to 8, and this is also equal to 20. So what here we can say that the multiplication of natural numbers is distributive over their addition. So we can say here yes. Similarly, we can prove for whole numbers also that the multiplication of whole numbers is distributive over their addition. So it will come yes over here. Let's see whether the multiplication of a natural number is distributive over subtraction or not. For that, again we'll take three numbers A, B and C. Then we have to prove that A multiplied by B minus C is equal to AB minus AC. Let's take, for example, I'll take A equal to 3, B is equal to 4 and C is 1. So first I'll take left hand side. Left hand side is equal to A into B minus C. A is 3, B is 4 minus 1, which is equal to 3 into 3, which is equal to 9. And now I'll take right hand side, which is equal to AB minus AC. AB is A multiplied by 4 minus A is 3 and 12 minus 3, which is also equal to 9. So we can say that the multiplication of natural number is also distributive over their subtraction. So we can say here yes. And for whole number also we'll get same result yes. We have additive identity. For any whole number A can be 5, 2, 3, 7, 8, 2, 50, any number. Whenever we add 0 to this number, we will get the same number. Means its identity is not changing. So 0 is the additive identity for all whole numbers. But 0 is not additive identity for natural number, as 0 is not a natural number. Now let's discuss additive inverse. If the sum of two whole numbers is 0, means additive identity, then two numbers are called as additive inverse of each other. So this is possible only if we have one number A and another is negative of that number minus A. If we add these two numbers, then we'll get 0. But we know that minus A is not a whole number. So we can say that there is no additive inverse for whole number. And for natural number also we don't have any additive inverse. Whenever we multiply any number with 1, for example a, into 1, we'll get same number. So what is this 1? 1 is known as the multiplicative identity for that number. And this 1 is multiplicative identity for both whole numbers and natural numbers. Next we have multiplicative inverse. Suppose if we multiply any whole number a with 1 upon a, then what we will get 1. A multiplied by 1 by a is equal to 1. Then 1 by a is known as the multiplicative inverse of that number. But we know 1 upon a is not a whole number or natural number. So we can say that there is no multiplicative inverse for whole numbers and natural numbers. Thank you everyone for watching my video.